Welcome back to Trend Guards. In today's explainer, we are objectively breaking down the verified technical specifications and the massive structural market shifts being driven right now by recent releases of Chinese open-weight AI models. As always, our mission is to deliver accurate, well-sourced analysis, separating the confirmed facts from the hype. We're going to look at exactly how a wave of open-source models, led by Moonshot AI, DeepSeek, Alibaba Cloud, and Zhipu AI, is fundamentally reshaping the global AI economy. Let's kick things off with a metric that is, frankly, just staggering. We are looking at a verified cost comparison for 1 million output tokens. For context, proprietary equivalents like Anthropic's flagship Claude Fable 5 currently sit at $50. DeepSeek V4 Flash, however, is executing this for just 28 cents. That is a 99% cost reduction. While Western frontier labs have spent billions building closed APIs behind strict paywalls, this open source wave is confirming that top-tier performance absolutely no longer requires premium pricing. To really grasp this shift, we have to look at the exact technical specs and official API costs. According to their official documentation, DeepSeek has locked in its V4 Flash API pricing at a highly aggressive 14 cents per million input tokens and 28 cents per million output tokens. Now, for enterprise developers trying to scale autonomous agents, API costs have traditionally been the absolute biggest bottleneck. This verified pricing structure immediately forces developers globally to completely reevaluate their budgets. And you might be thinking, well, low price probably means a compromise in capability, right? Actually, no. We are seeing strict performance parity. Terminal Bench 2.1 is a verified benchmark that evaluates how effectively an AI agent navigates real system command lines, debugs servers, and executes bash scripts. DeepSeek V4 Flash scored an 82.7 here, officially placing it ahead of Anthropic's high-tier Claude Fable 5, which scored 80.5. It's literally verifying its superiority over a closed-source model when it comes to executing real complex system tasks. Because of that incredible benchmark efficiency, the average cost of a completed agentic task comes down to exactly 3 cents. Think about that for a second. When a model that costs 3 cents per task outperforms a proprietary model that historically costs over $2 for that exact same execution, enterprise adoption completely ceases to be a debate. It just becomes an economic certainty. So the crucial question is, how exactly does DeepSeek achieve this execution efficiency without burning through unnecessary reasoning tokens? According to the verified technical docs, the pipeline relies on 3 distinct steps. Step 1 is task decomposition, which uses repost-trained agentic guidance to split complex system tasks into modular, non-redundant commands. Step 2 is real-time terminal interaction, utilizing minimal harness execution to listen to standard output and error flags in real time. And finally, step 3 is error recovery and final verification. Now, step 3 is the real magic trick for cost control. If a system dependency fails during execution, the model utilizes what's called self-healing code adaptation. Basically, it instantly rewrites its execution script without resetting the chat context window. By not having to reload the entire context upon hitting an error, it preserves token usage. And that is exactly how it maintains that verified 3-cent average task cost. Moving beyond just the cloud APIs, we need to examine the verified technical reality of running these multi-trillion parameter models locally. Looking across the ecosystem, 4 titans really stand out right now: DeepSeek V4 Flash, Kimi K3, Qwen 3.8 Max, and GLM. By comparing their architecture, like their mixture of expert sizes, and their open license status, we can see exactly how these models are granting enterprise developers some undeniable technical advantages that are disrupting the traditional Silicon Valley monopoly. Take the verified specs for Moonshot AI's Kimi K3, for instance. It features a massive 2.8 trillion parameter mixture of experts architecture with 104 billion active parameters. Historically, running a model of this scale required server clusters costing hundreds of thousands of dollars. But Kimi K3 utilizes Unsloth's dynamic 1-bit and 2-bit GGUF quantizations. This compresses its memory footprint by up to 62%. That officially makes it possible to execute the world's strongest open-weight model locally right on standard workstation hardware. At the same time, we have Alibaba Cloud's Qwen 3.8 Max. This model introduces a confirmed native feature called dual thinking modes. This allows developers to efficiently route computational power based on the specific query. You've got a thinking mode for complex multi-step reasoning and a non-thinking mode for ultra-low latency rapid responses. And it supports this hybrid architecture across 119 different languages, making it incredibly versatile for global use. And we certainly can't forget models like Zhipu AI's GLM series, which are utilizing open MIT licensing for enterprise system integration. The real-world impact here just cannot be overstated. By offering this level of raw technical capability under an open license, it grants developers true data sovereignty. It fundamentally eliminates that mandatory reliance on Western cloud infrastructure, and it enables fully local, highly secure, sovereign deployments. Let's pull back and look at how this structural progression fits into the broader industry context, creating a self-reinforcing global ecosystem. Back in late 2025, enterprise developers faced a massive, high API cost bottleneck from proprietary labs. Then, by early 2026, we saw MIT and Apache 2.0 standardization as Chinese labs embraced open licensing, which allowed startups to self-host without platform lock-in. Mid-2026 brought those critical architectural innovations that drastically cut local VRAM requirements. And all of this structural progression led us directly to August 2026, the open source parity epic, where open models officially match or exceed proprietary frontier performance. So the confirmed reality is this: we are witnessing a fundamental shift in the AI landscape. Developers globally now have access to frontier-level intelligence, long context windows, and local hardware execution. And they have all of this at a mere fraction of the cost of closed proprietary APIs. The open source movement is actively decentralizing access, putting absolute high-level capabilities directly into the hands of engineers worldwide. As you review these verified benchmarks and evaluate your own infrastructure strategies moving forward, the financial and technical data points clearly mean one direction. So I'll leave you with one critical question to consider for the future of your deployments. Are you currently hosting open-weight models locally to guarantee data sovereignty and cost efficiency? Or are you still relying on closed proprietary APIs?
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.